So putting those pieces together, here's the essence of a TCP server. Get the address for this for anything on the local machine at a given port number, saying that we want a TCP connection and also that we're going to be a server. Create a socket at that address and bind it. Then we don't need our local addresses anymore. And then start listening. So this causes ls to be a listening socket, which we can pass to accept to receive a connection. That connection will be from some address that we're not going to pay attention to. Instead, we'll just read data from a client, print it back out just like our earlier server did, print out a new line, but we're also going to tell the other end how much did we actually get before we close it. And then on the client side, we do similar sorts of things. Get the address of the host at a particular port, create a socket, connect to the server. Don't need the addresses anymore. We'll make this client be able to repeat the message any number of times. And so we write that message, copies times, to the server. We make sure that all the data we tried to write went through. And then the server is going to tell us back how much data it received. So we can read that. Let's go back. The server actually wrote that not as a string. It just took a size t here and wrote the raw size t bytes into the stream. So we receive it on the other end. This is going to work as long as both our server and client are little endian and have the same notion of size t, which they will for us. And then report back what the server, how many bytes the server got, and then close the stream. So here we go, just to look at the full information TCP server. It's just got a little error checking, otherwise it's basically what we saw before. And TCP client.c has some error checking for the arguments similarly, and otherwise is basically what we wrote. So let's try TCP server at 1024, and then TCP client talking to localhost, port number 24. Let's say hello. So you see the server received hello, and it told us back that it got 5 bytes. And if we do it 10 times, it got back 50 bytes. And if we do it 100 times, it got 500 bytes. So that's an improvement from before. If we do it 1,000 times, 1,000 times it says it got 85 bytes. So that's not what we were expecting. What went wrong here? Well, the thing that went wrong is how does the server know that the client is done? It's reading some number of bytes based on the buffer, but much like pipes, it might be that it reads 85 because that was the first, let's see, how many times is that? 17 times that hello was written. And it just happened that after 17 writes, the server got to go again. So if we try another time with 1,000, maybe we get a different number. That time all 5,000 went through. The problem here is not that packets are getting lost, just that our protocol is broken. There's no way, the way we've written it, the server doesn't know whether the client is done or just to send a certain amount and will send more. Another issue is that this read could get interrupted by a signal. It could be maybe we know that we want a certain amount of data, but only some is called, and so read will just return us however much is available.